Space, the cosmos, infinity. 13.8 billion years ago, there was nothing, or as Neil DeGrasse Tyson describes it, nothing, until a single point, possibly smaller than an atom with unfathomable density and heat, explodes into what we know as the universe. In an instant, space, gravity, and time were created, and about 400 million years later, the seemingly infinite spew of particles from this rapid expansion finally formed into the stars. Then the gravity of these stars pull each other closer and then farther apart into a spinning dance of millions and millions more stars until you get a galaxy. Then hundreds to thousands of galaxies into a supercluster, and then an even bigger supercluster to contain the former. Oh yeah, guys, space is unimaginably big. In fact, big is an understatement, and there are a lot of cool and terrifying things out there like black holes, gamma ray bursts, quasars, magnetars, pulsars, and the ultra-rare life, humanity, us. So put on your NASA t-shirt, grab a drink, and join us on this interstellar episode of Tipler's 2 Cents. You know, Sean, one day I really want to have sex in space.
Yeah, well, you have to have sex on Earth first, you fucking nerd.
Hello once again, drinkers and thinkers, to episode 24 of Tipler's 2 Cents. I am your host and creator, Chris Walters, and joining me as always is my indentulous co-host and co-creator, Sean Knox.
I had nothing else to say.
Thank you guys for tuning in for today's episode on outer space, the planets, and other cosmic bodies. Should be a fun one. But before we get into that, let's go ahead and tell everybody what we're drinking today. Now, for me, I went with something I'm not sure of, but, I haven't done a lot of IPAs lately, and I'm trying to get back into it, so I picked up what's called Drumroll Hazy Pale Ale. And it's got a decent enough looking can, so, I usually kind of go based off of what the artwork looks like on the can, because I'm a hipster like that, but I think it looks pretty cool. So I'm going to give this one a try. I've never heard of drumroll. Anyway, Sean, what are you drinking today?
I am drinking a fine vintage plastic Smirnoff Ice. not even Smirnoff Ice. Just
at least
Smirnoff.
It's not. At least it's not Popov or what's the other one? What's the other gross one?
Rare Reserve.
Yeah, something like that, or like Everclear or some shit.
Everclear's good.
At least you're not drinking that. Smirnoff's okay.
Yeah, if you want to drink vodka, get Smirnoff or Grey Goose. Svedka's pretty good too. But really, you don't, as long as it doesn't actually have a taste, that's the whole point. That's the whole point of vodka. No taste and gets you fucked up. So I'm going to be taking shots of vodka.
All right. Well, today, in the spirit of Black History Month, as well as today's episode, we are toasting to Guion Bluford, the first black American to go into space. Incredible. Born in Philadelphia, Pennsylvania on November 22nd, 1942, he went on to receive a Bachelor of Science degree in Aerospace Engineering from Pennsylvania State University in 1964, a Master of Science degree with distinction in Aerospace Engineering from the Air Force Institute of Technology in 1974, a doctorate of, philosophy degree in Aerospace Engineering with a minor in laser physics from the Air Force Institute of Technology in 1978, and a Master in Business Administration from the University of Houston-Clear Lake in 1987. He then became a NASA astronaut in August 1979. So, wow, he did a lot. Bluford was a veteran of 4 space flights. Unfortunately, this astro juggernaut died on February 1st, 2003, when the Space Shuttle Columbia and the crew perished during re-entry. So, I mean, you sound like an incredible human being. Thank you for everything you've done, and thank you for being a good stand-up example for the Black community. And it's an honor to celebrate your legacy here on our show and during your Black History Month. So for what it's worth, we Tipplers salute you, Guion. Godspeed. Cheers.
Mm. Is it all right?
Huh. It's all right. The flavor is really not as bold as I was thinking it would be. Like, normally pale ales seem to have like a really, bitter, harsh taste to it like right away, but this one's kind of light.
Yeah.
Not bad. Not bad.
Also,
so for anybody that's wondering.
Also, Guion, fun fact that I just didn't put in, he also did one of those flights that he took. One of the 4 space flights that he took was also on the Challenger, on one of its earlier missions. Which,
cool.
If we all know what happened to the Challenger, it was pretty similar to what happened to the Space Shuttle Columbia. So, I don't know who the fuck was out to get this guy, but he was still a hero.
Yeah, that's awesome. But all right, guys, now that we got our toast out of the way, let's make like Guion and head to the stars. So let's start talking about our neighboring celestial bodies, the planets.
So, just starting off, we're going to exclude Earth from this list because fuck this place. I am so fucking upset with Earth right now.
That's fair.
And also go in order from closest to farthest from our sun. So, all right, let's go. Name for the Roman messenger of the gods and zipping around the sun in only 88 days. Mercury is the closest planet to the sun, and also it's the smallest, only a little bit larger than Earth's moon. Because it's so close to the sun, about 2/5 the distance between Earth and the sun, Mercury experiences dramatic changes to its day and night temperatures. Day temperatures can reach a scorching 840 degrees Fahrenheit. That's 450 degrees Celsius for those across the pond might be listening, which is hot enough to melt lead. Meanwhile, on the night side, temperatures drop to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. Mercury has a very thin atmosphere of oxygen, sodium, hydrogen, helium, and potassium, and can't break up incoming meteors, so its surface is pockmarked with craters just like the moon. Over its 4-year mission, NASA's Messenger spacecraft revealed incredible new discoveries that challenged astronomers' expectations. Among these findings was the discovery of water ice and frozen organic compounds at Mercury's North Pole, and that volcanism played a major role in shaping... Volcanism, yeah. Volcanism played a major role in shaping the planet's actual surface. So, Chris, how would you imagine, like, Mercury? Because it's almost like hell.
That's basically what it sounds like.
It kind of just sounds like it's hell, like, because it's just, it's fucking on fire, or it's freezing cold. Honestly, I didn't even know before making or writing this that that it even got cold. I figured it would always be hot because it's so close to the sun.
Yeah, well, I guess I guess in a way it makes sense, because if we think about it, winter is when the sun is closest to the earth, right? I don't think I have that wrong.
Yeah.
So I guess it would be kind of, if you took that same logic and applied it to Mercury, then I guess you would have to imagine it's cold most of the time, or at least a good part of it, because that would mean it would take... So, yeah, that planet would have to take the longest to get around the sun, right? Or would that be the fastest?
It would be the fastest, because it's closest to the gravitational pull, so it's just like...
Yeah, okay.
Yeah, I think...
Still, that would mean that a part of it is, the back of it is always, not facing the sun because of its rotation.
Yeah, you're right, because it's a Mercury's year is 88 days, but that doesn't necessarily mean that its rotation is consistently just as fast. So yeah, you're right. It probably just means that it's turning really slow. So the side that is facing the sun is hot, but that doesn't necessarily mean that it's like spinning super fast. So yeah, you're right.
Take that at face value. We're no scientists here, or astronauts or anything.
But
That's just my understanding of it.
I will say that is a very nice observation.
I'm glad I did good on that one. But yeah, I mean, Mercury sounds pretty cool, and it's funny. You never really hear anything about like these other planets, and it's like, I don't know. It's just nice to even get just the smallest amount of detail on some of this stuff. Because I mean, like Mercury for one, like just it being the closest planet to the sun, you'd feel like I would want to know a lot about it. Like, how is it even still there, being closest to the the hottest thing we can even think of? I don't know. It's just interesting to think about. Anyway, next thing we're going to talk about, named for the Roman goddess of love and beauty, and the second planet from the sun. It's also named after the famous girls' razors, Venus.
God damn it.
No, it's not named after the razors, but Venus is Earth's twin in size. Radar images beneath its atmosphere reveal that its surface has various mountains and volcanoes, but beyond that, the two planets couldn't be more different. Because of its thick, toxic atmosphere that's made of sulfuric acid clouds, Venus is an extreme example of the greenhouse effect. It's scorching hot, even hotter than Mercury. The average temperature on Venus's surface is 900 degrees Fahrenheit or 465 degrees Celsius. At 92 bar, the pressure at the surface would crush and kill you. And oddly, Venus spins slowly from the east to west, the opposite direction of most of the other planets, which is bizarre as fuck.
Yeah.
The Greeks believed Venus has two different objects, one in the morning sky and another in the evening. Because it is often brighter than any other object in the sky, Venus has generated many UFO reports. And I do remember reading that before, that a lot of people think they see a UFO, but it's actually Venus, which is weird. I'm guessing it just must be because of all the gases on the planet that make it bright.
Yeah, I'm assuming so. I'm assuming that it reflects light really well, and that's why it shines so brightly during the day. But yeah, I mean, fucking just the fact that, like, if you went on, for me, the fact that if you went on Venus's surface, it's basically like going to the bottom of the Marianas Trench for us, because you would just be like crumpled like a piece of paper.
Yeah.
Another quick thing that I wanted to mention was Venus is actually second to Mars in order of colonization, because technically its atmosphere is sustainable, its surface just isn't. So, Cloud City, anybody? If we actually found a way to make cloud cities, we can fucking go all Lando Calrissian on that motherfucker. Wouldn't that be dope?
Or Bioshock.
Yeah, or Columbia.
A little Columbia.
Oh, jeez, I love planets so much. I have such a fucking nerd boner right now. Like, you have no idea. I love the fact that we got to make this. Anyway, the third one is Earth. Earth, of course, the third planet from the sun. But like I said before, fuck this place and let's move on to Mars.
You should know everything about Earth by now. You live here.
Yeah, if you
or
don't,
at least enough to know, enough about it. Whatever.
Yeah, we have oceans and we have terrible people. So, named for the Roman god of war, and the fourth planet from the sun is Mars, and it's a cold, desert-like place covered in dust. The dust is made of iron oxides, giving the planet its iconic red hue. Mars shares similarities with Earth. It is rocky, it has mountains, valleys, and canyons, and storm systems ranging from localized tornado-like dust devils to planet-engulfing dust storms. Substantial scientific evidence suggests that Mars at one point, billions of years ago, was a much warmer and wetter world. Rivers and maybe even oceans existed. Although Mars's atmosphere is too thin for liquid water to exist on the surface for any length of time, remnants of that wetter Mars still exist today. Sheets of water ice the size of California lie beneath Mars's surface, and at both poles are ice caps made in part of frozen water. In July 2018, scientists revealed that they had found evidence of a liquid lake beneath the surface of the southern pole's ice cap. It's the first example of a persistent body of water on the red planet, and scientists also think that ancient Mars would have had the conditions to support life to a point, like life like bacteria and other microbes, not life such as us. Hope that signs of this past life and the possibility of even current life forms may exist on the red planet, has driven numerous space exploration missions to Mars, and is now one of the most explored planets in the solar system. As far as actual colonization goes, what do you think, or what are your hopes are for colonizing Mars? Because I love the idea of colonization, especially within our own solar system. We're not fucking hurting anybody. It's not like colonizing places on Earth, because that was hard, and there's genocide and shit. But going to colonize the moon or Venus and Mars, like, they're all possible ways. Do you want that to happen in general?
Yeah, I definitely do. I mean, I think we talked about this a little bit back on like episode 1, and I would encourage you to go listen to episode 1, but it's an awful episode, so maybe don't.
Yeah, no, the subject matter is good, but the audio
the subject
is fucking
is good
terrible.
and what we're talking about, but I mean, yeah, we had just started. I wasn't using a very good mic. I don't even think his sounded that great. We didn't know what we were doing yet. So
yeah, I was just bad at like
still
editing.
Had good talking points. But either way, we were talking about like colonizing other planets and stuff like that. And it just boils down to the fact that I don't think we are ever meant to permanently stay here as a race. I mean, I think that's why all the other planets and stuff exist, is for us to find new frontiers and all that stuff. And yeah, Mars is kind of like that one that I think everybody just for decades has known that this is the planet that we're eventually going to move to. So I don't even think it's a matter of, are we going to colonize Mars? I think it's just a matter of when. And I really hope that it's in my lifetime. I remember reading stuff about Elon Musk wanting to colonize Mars, and if I remember correctly, he was saying it was going to be within my lifetime. I just can't remember. Yeah, so I'm hoping that happens.
I think he wants to do it in the next like 20 years.
Yeah, and I mean, I hope that happens, because I would like to see it. I don't know if I ever want to go there myself, but I would really like to see it, like on the fucking news or something. Just know that there's a colony of humans living on Mars.
And here's the thing: it's not. Well, I mean, I'm not saying it wouldn't be hard. Of course, it's gonna be fucking hard. But like, the first thing that comes to mind is like being able to terraform planets, and that's unrealistic. I mean, Earth in its solar system, or in our solar system, is in such a fucking good zone. I forgot I think they call it the Goldilocks zone. It's basically the ring around the sun that is the perfect distance. Because if you're any farther, you get too cold. If you're any closer, you get too hot. And it also, it helps form water and all that shit. And I think Mars is within the Goldilocks zone or just outside of it. Either way, it's not that we can't colonize certain planets that aren't within a Goldilocks zone. It's just that it's going to be a really pain in the dick way to fucking live, because for probably the moon and Mars, if we were to colonize it, it would be subterranean. We would have to go underneath the surface and live subterranean. Whereas, like I was saying earlier with Venus, if we can make a way to like make Cloud City or make a version of Columbia or something like that, that would be preferable, because the atmosphere is perfectly fine. But just go any lower and you're completely fucked. However, like with...
Yeah, but we could also do the same on Mars, too, by just, like, kind of creating our own... generating our own atmosphere in our living conditions instead of trying to go subterranean.
Yeah, but it really becomes a message of which is harder and which can we do first. Because if you go and become subterranean for a little bit and just kind of set your goal or set a goal and have so many people there, then you have people already on Mars that can go outside of their subterranean base and work on shit, and then maybe start terraforming, maybe start blowing up some nukes, because that's pretty much what you need to do to cause a greenhouse effect on Mars. You have to really fuck that planet up. And that's still going to take hundreds of years to terraform a planet, at least the way that we know how to. We don't have any fucking terraforming machine like in the Man of Steel. But going subterranean on the moon and Mars is probably the preferable way to go. Venus, I really see no way to go to Venus right now. I don't think we even have the technology to create a floating city. And, outside of making like a space station that would orbit the planet, but we can pretty much already do that. I think it's really just about the practicality of doing such a thing, because you would pretty much only want to make a space station of that size if you were planning on leaving the Earth permanently, and in the scope of the next 50 to 100, actually probably like till like 2050, I think that's when shit's gonna really start being a pain in the ass. So, yeah, as far as terraforming a planet, there's no fucking way. And as far as making a space station, it's probably not gonna happen anytime soon. So, anyway, that sent us.
Yeah, but just real quick too, I'm pretty sure that we just landed a new rover on Mars.
Yeah, Perseverance.
Yeah. So I think we're making leaps and bounds towards it happening. So I would like to see it. Anyway, next planet, named for the ruler of the Roman gods and the fifth planet from the sun, Jupiter is a giant gas world that is the most massive planet in our solar system, more than twice as massive as all the other planets combined, according to NASA. Its swirling clouds are colorful due to different types of trace gases, and a major feature in its swirling clouds is the giant red spot, which many of you should know from elementary school, which is actually a giant storm more than 10,000 miles wide. It has raged at more than 400 miles per hour for the last 150 years at least. Jupiter has a strong magnetic field, and with 75 moons, it looks a bit like a miniature solar system. And that is really cool, actually. I didn't know it had 75 moons. That's a lot.
Yeah, it has a motherfuck ton. And I think, speaking of colonizing, I can't remember if it's Jupiter or Saturn that has Titan. Because Titan's another moon that's pretty fucking huge. That
I think it's Saturn.
Yeah, it might be Saturn, but that's one of those things. It's like obviously we can't go to Jupiter, or we can't go in Jupiter because it's technically not.
It's a gaseous.
Yeah, it's
planet.
not terrestrial. But having that massive gravitational pull to have that many moons, that's even fucking more ground. That's more space that we can fucking go. I want to be in space, Chris. I want to be in space so bad. God damn it.
Well, and dude, just talking about a giant gas planet, what the hell even is that like? You know what I mean? Oh, God, if there was some dying wish I could get to be to have some sort of weird existential trip through space and time, I would love to do that, just to be able to pass through fucking Jupiter and experience what that even means to be a gas planet.
Yeah,
it blows my mind. I can't even comprehend how a planet could just be made of gas. It's weird.
All right, I can't keep nerding out, so let's just keep going because there's still plenty of planets left. Named for the Roman god of agriculture and the sixth planet from the sun, Saturn is known for most of its rings. When polymath Galileo Galilei first studied Saturn in the early 1600s, he thought it was an object with three parts, a planet and two large moons on either side, not knowing he was seeing a planet with actual rings around it. And this stumped the astronomer. The stumped astronomer entered a small drawing, which was a symbol with one circle and two smaller ones, in his notebook as a noun and a sentence describing his discovery. More than 4 years later, Christian Huygens proposed that they were rings. And the rings are made of, ice and rock, and scientists are not really sure how they formed. But the gaseous planet is mostly hydrogen and helium and has numerous moons. And I fucking wish that I put if it has Titan or not, because I'm obsessed with that moon as well.
Yeah, I'm pretty sure it's Saturn.
Yeah.
I'm pretty sure Saturn's moon is Titan. I'm not 100%, but I'm pretty sure.
But honestly,
Saturn's another one that I think is cool as fuck too, with just having the rings and stuff. There's so many things with space that blow my mind and that I would just love to know more about, but my brain is too stupid.
Well, that's the thing. Every single planet. That's why I wanted to start this way. It's because every single fucking planet just in our solar system is so insanely unique. And you think of any planet in the solar system, I feel like most people are going to think of Earth first, and then Mars second, as far as popularity goes, and then probably Saturn or Jupiter, just because Saturn has just that iconic symbology,
that look to it.
Symbology. Yeah. What is this fucking Boondock Saints? The symbolism.
Symbology.
God damn it.
The symbolism.
But yeah, the symbolism of the shape of the planet is so iconic that there's no way that you could ignore Saturn. But just the fact that every single planet is so fucking unique. But anyway, continue, Christopher.
So the next one we got is named for the personification of heaven, and the seventh planet from the sun, Uranus, is an oddball. It has clouds made of hydrogen sulfide, the same chemical that makes rotten eggs smell so foul. It rotates from east to west, like Venus, but unlike Venus or any other planet, its equator is nearly at right angles to its orbit. It basically orbits on its side. Astronomers believe an object twice the size of Earth collided with Uranus roughly 4 billion years ago, causing Uranus to tilt. That tilt causes extreme seasons that last 20 plus years, and the sun beats down on one pole or the other for 84 Earth years at a time. The collision is also thought to have knocked rock and ice into Uranus's orbit. These later became some of the planet's 27 moons. Methane in the atmosphere gives Uranus its blue-green tint. It also has 13 sets of faint rings. And I know some of you want me to say Uranus, but I'm not going to say that. It's called Uranus. That's how it's actually supposed to be pronounced.
I was so hoping you would say Uranus because it's named for the personification of heaven. And I was hoping to God.
Heaven is in Uranus.
I was hoping to the God above that he would make that connection.
Like, well, if we think about where the male G-spot is, then technically that is a personification of heaven.
Yeah, you stick a finger in there and it makes me fucking cock back like a shotgun.
But we're getting way off topic on that one.
But yeah. Oh, fuck. But yeah, okay, so Uranus, like Chris said, it's on its side. So if you ever see a picture of Uranus, it has a ring that goes like if this is the ball. And sorry for all of you audio listeners on there, fucking check out the YouTube channel if you want to see what I'm doing. But it's if you see it as a ball, the ring is going vertically for us anyway, because that's the thing. Vertically and horizontally really don't mean jack shit in space, but for us,
it's all perspective. From an outside perspective. If you were on the planet itself, you wouldn't notice. So.
Yeah, but yeah, it's the ring's going vertically. So if you ever see a picture of Uranus, it's basically just a blue ball with fucking a ring around it going vertically, and the ring's very faint. But yeah, Uranus still a very fucking cool planet with a very unfortunate name. So the next one is named for the Roman god of water and the eighth planet from the sun. Neptune is about the size of Uranus and is known for supersonic strong winds. Neptune is far out and cold, and the planet is more than 30 times as far from the sun as Earth. Neptune was the first planet predicted to exist by using math before it was visually detected, and irregularities in the orbit of Uranus led French astronomer Alexis Bouvard to suggest some other planet might be exerting a gravitational tug. German astronomer Johann Galle used calculations to help find Neptune in a telescope. And Neptune is about 17 times as massive as Earth and has a rocky core. So I actually didn't know that. Because I thought Neptune was another...
a rocky core, like Sylvester Stallone's in there.
God damn it. No, I'm
a planet.
You gotta keep fighting harder. No,
sorry, I'm still coming down off an edible and I'm drinking, so give me a little leeway.
No, I always thought Neptune was a gaseous planet, but
I did too.
Yeah, it doesn't really say. Yeah, it doesn't necessarily say in my description that it's not a gaseous planet, but it has a rocky core. So, I mean, okay, so essentially every planet does have a core, but the core is what causes its gravitational pull. So, like in Jupiter and Uranus, it doesn't necessarily mean that there's not enough, that it's not rocky, because the texture might actually differ, but if you went to Uranus's or Jupiter's core, it would just be a hyper dense mass of gas, like basically like a super thick fog, if you will, because that's the kind of gravitational pull in that, and then it would expand and so on and so forth. So every planet does have a core, but this one has a rocky one, just like ours. Where actually ours has a molten core, which I guess technically you can say it's rocky still, but whatever. Neptune, very cool, and it's named after a fucking water god, so that's dope.
Yeah. All right, last but not least, named for the Roman god of the underworld and the once ninth planet of the sun, Pluto is unlike other planets in many respects. It is smaller than Earth's moon. Its orbit is highly elliptical, falling inside Neptune's orbit at some points and far beyond it at others. And Pluto's orbit doesn't fall in the same plane as all the other planets. Instead, it orbits 17.1 degrees above or below. From 1979 until early 1999, Pluto had actually been the 8th planet from the Sun. Then on, from February 11th, 1999, it crossed Neptune's path, once again became the solar system's most distant planet until it was redefined as a dwarf planet. It's a cold, rocky world with a tenuous atmosphere. Scientists thought it might be nothing more than a hunk of rock on the outskirts of the solar system, but when NASA's New Horizons mission performed history's first flyby of the Pluto system on July 14th, 2015, it transformed scientists' view of Pluto. Pluto is a very active ice world that's covered in glaciers, mountains of ice water, icy dunes, and possibly even cryovolcanoes that erupt icy lava made of water, methane, and ammonia. That is fucking... that is so fucking cool, dude.
That's fucking awesome.
Icy volcanoes? Like, what the fuck? That's fucking insane. Ah, dude, that's so cool. And I'm glad that people reestablished Pluto as a planet. Like, I was one of those people that was just like, I felt fucking... I know it's not a living thing, but I felt bad for Pluto when they were like, it's not a planet. Like, well, it's always been a planet. It's in books.
It's not a planet. It's still not a planet.
I know, but they reestablished it as like a
dwarf
planet.
Yeah, they put it in a subclass, but yeah, it's still a very big part of our solar system. So I can't get over those cryovolcanoes. That's dope as shit.
Yeah, that's so cool, dude.
Okay, so broad discussion. How fucking lucky do you think we are to be on this planet and to exist in the first place? Because the amount of how can I say, like, uniqueness and variety for just the planets within our solar system, which is fucking minuscule in the scope of the universe. How goddamn lucky do you think we are to be on Earth? And, like, how unique is Earth? Like, granted, I said I didn't want to talk about Earth, but the fact of how fucking...
In this regard, we gotta talk about it.
Yeah, but in this regard, like you said, it's so unique. And just as unique as the other planets, but it literally has little babies on it just running around. And I'm gonna go into this a little bit more later in the episode because I have a really fucking big point to make. But tell me how you feel just about the scope of our solar system. How fucking lucky we are.
Yeah. So I mean, like, it's a 1 in a billion chance. You know, the circumstances for life to exist. It's not even random. It's just so... It takes so much for this to come about. For a human to exist, it takes so much, and it's honestly mind-blowing. And not to turn this conversation to a religious / scientific debate, but that's one of the reasons that I personally am starting to lean towards the religious side. I've always been a very logical and scientifically factual driven person, but there's just some of those things out there where you're like, how in the fuck, like, even with all the science and all the math, all those other things that we can do, how can this even be possible? How can it even be possible for there to be life on just one planet out of 8 or 9, and we've never found any life anywhere else? And it's just like, it's just one of those things where you're like, it can't just be random blind luck. And if it is, that really sucks. But yeah. It's hard to believe. But no, at the same time, it really could be. It really could just be blind luck that we just happen to be here. And in that case, we're the luckiest sons of bitches in existence.
Yeah, I'm not going to spoil it. I'm not going to make my point before it's time. But I do go into this. So bear with me. But yes, we are insanely fucking lucky to exist.
Yeah.
But yeah, I'm gonna let Chris take it away because it's time. It's time for something.
All right. Yeah, now that we've had a little bit of a warm up on our astronomy, we can get into the bigger, badder other cosmic bodies. But first, it's time for
Tippler's Tidbit.
All right. Today's Tippler's Tidbit is going to be this. Might seem strange that there are alcoholic clouds in space, but a great deal of complex molecular chemistry goes on between the molecular clouds and dust in outer space, and all sorts of chemical compounds exist there. Alcohol is a relatively simple molecule made of relatively abundant elements, hydrogen, carbon, oxygen, so it shouldn't be surprising that it exists in large quantities in space. In a region known as W3OH, only about 6,500 light years away, there's a giant cloud of alcohol. Unfortunately, it is methyl alcohol, commonly known as wood alcohol, so it isn't suitable for drinking. There is some ethyl alcohol, the drinkable kind, there as well, but it's not nearly as common within the cloud. So unfortunately, you can't just take a nice little space trip and get all wasted while you're out there drifting through the void.
But knowing the universe, there has to be a giant cloud of ethyl alcohol somewhere, and we will fucking find it.
Yeah, that's what I was going to say, is the fact that there is some ethyl alcohol out there gives me some hope to think that maybe there's just a full drinkable alcohol cloud out there in space. Anyway, guys, this has been your Tippler's Tidbit.
Tippler's Tidbit.
Now that we've got your Tippler's Tidbit of the day out of the way, I think it's time to talk about the other cosmic bodies.
Okay, so first of all, guys, if it wasn't already obvious, I have written this script, which means that there are some things that are out of the ordinary. We have a thing here. If this is the first episode, hi, by the way, hi, I love you.
Hi.
The point I'm trying to make is within Tippler's Tidbit, we usually have a fake ad, and it also gets people to try to message us about potentially getting us sponsors and stuff because we have a fake sponsor. I was too dumb to write in a fucking joke, so I'm sorry. But
we'll get you next time. I'll
we'll
have
make
an extra funny one for you.
Yeah, we'll make up for it. Me and Chris will make you feel good, baby. I swear to God, we'll make it all better.
Make you feel good.
But so there it is. Sorry for any of those listeners that consistently listen to us.
Might have been looking forward to that.
Yeah. But anyway, okay. So all the cosmic bodies that are on this list aren't listed in any particular order, and we pretty much just picked them out of sheer nerd love for the topic. But if you're not a fan of astrophysics, I personally compare it to like comic book love, like weighing the strength and power of heroes and villains, and then pitting them against each other, similar to how we view these celestial entities. Motherfucker, it's time for another shot. Except it's delightfully terrifying because they're fucking real. It's real. I don't know, dude. It's so, oh my God, I love space so fucking much, Christopher. It's so awesome. Because I can talk about Superman all goddamn day, but Superman doesn't exist. But you know what does exist?
Without the sun.
Yeah, the fucking sun. The sun exists, and that shit can just explode and wipe out all life as we know it. It's fine. It's cool.
Yeah, that's terrifying. I want to talk about that a little bit later.
But yeah, so take our sun for example. In the scope of the universe, our sun itself is pretty insignificant, but if it wasn't there, we wouldn't exist, like we mentioned earlier. But more on that later. Let's talk about stars in general for right now, because they are pretty much the star of the show when it comes to ultra-powerful cosmic superpowers, because they're fucking important.
So yeah, starting with protostars. A protostar is what comes before a star has formed, a collection of gas that collapsed from a huge molecular cloud. This stage in stellar evolution lasts about 100,000 years, so yeah, pretty short time. During this period of time, just as the collection of gas has collapsed to form the protostar, the increase of gravity and pressure causes the protostar to collapse down. This process leaves a pre-main sequence star, which later turns into a main sequence star when the hydrogen fusion starts. Next comes the T-Tauri stars? T-Tauri stars.
Yeah, Tauri. Yeah.
T-Tauri?
Yeah.
T-Tauri? Yeah. T-Tauri stars are, or pre-main sequence stars, are what comes after protostars and before main sequence stars. These stars symbolize youth, and they are named after a young star in the Taurus star-forming region. At this point in stellar evolution, the gravitational pressure that holds the star together is also the source of all of its energy. At this stage, they do not have sufficient pressure or a high enough temperature in their cores to onset nuclear fusion. However, they are about the same temperature as main sequence stars, only brighter because of their larger size. A star will remain in its T-Tauri stage for approximately 100 million years before evolving into its next form. Wow.
Can we just talk about how fucking old stars are?
Yeah, like, fuck, that's crazy.
Shit. So then, there are main sequence stars. Most of the stars in our night sky in the entire universe are main sequence, also called dwarf stars. Our beloved sun is a main sequence star, so our sun is a dwarf star, as well as the brightest star in our night sky, which is called Sirius. These stars can vary in size, brightness, and mass, but they all have the same process happening in their cores. They are converting hydrogen to helium, creating a vast amount of energy. Dwarf stars are in a state of hydrostatic equilibrium, which means that gravity is pulling the star inward, while the pressure from the fusion reactions is pushing the star outward. These forces balance each other out, so the star remains a sphere. And the size of these stars depend on their mass. Some stars can even become 100 times the mass of the sun. God damn it. How this space is so cool. God fucking... I love space. The next stage in a star's life happens... the next stage in a star's life happens... I wrote this shitty. They're called red giants. This is the next stage. Red giants and a star becomes one when all the hydrogen in its core is used up and the fusion stops. This means there is no longer an outward light pressure or to counteract the inward pressure pulling the star together, and the life of the star continues when the shell of the hydrogen around the core ignites and causes the star to massively increase in size. So basically, there's no inward gravitational pull anymore. It's just expansion.
Now it's just expanding.
Yeah. The star then becomes a red giant and can be up to 100 times bigger than it was in its main sequence stage. So this basically means that if a star already was 100 times the mass of the sun, because the mass can differ, when it goes into its red giant stage, then it can increase 100 times that. So I forget the star that I'm thinking of as name, but there's a red giant. It's in what's that movie called? Passengers. You know what I'm talking about?
Yeah,
Beetlejuice.
I know what you're talking about too.
Beetlejuice,
Yeah,
I think.
yeah.
Beetlejuice is fucking huge, okay? This star is fucking gantic, and that's essentially why it becomes so big. It's because it depends on the mass of the star initially. So if it already has a fuck ton of mass, then when it goes into its red giant stage, it's just going to expand even more so. I don't personally know if Beetlejuice is already a red giant or not. I feel like it's not. But it might be.
I think it is.
Yeah,
I think so, right?
Yeah, it could be, to be honest. But yeah, so if it is a red giant, that's why it's so insanely big, and you can look up like YouTube models and stuff like that for the difference between our sun and Beetlejuice, because motherfucker, I think Beetlejuice is like the size of our solar system or something like that, spherically.
Yeah.
Anyway, this stage of stellar evolution only lasts a few 100 million years, and its lifespan is so short because the star has so many layers of helium to consume before it runs out and becomes a white dwarf. Oh my god, I love space. So cool.
Yeah, and so a star then turns into a white dwarf when it consumes all the layers of helium in its core and runs out of other elements to use as fuel. When the outward light pressure from the fusion reaction stops, the star collapses inward from its own gravity. However, even though the fusion reactions have stopped, the star still shines because of its immense heat. It will take hundreds of billions of years for the white dwarfs to cool down completely, meaning that we still don't know what will happen to the stars after this stage is over. There are also red dwarfs. These belong to the main sequence star group. Red dwarfs are most common stars in the universe. The mass of these stars is so low that they are much cooler than the stars like our sun, and they can keep the hydrogen fuel mixing in their core. Therefore, they can save their fuel for much longer, and because of this, astronomers estimate that red dwarfs will burn for up to 10 trillion years. 10 trillion years. Dude, this is why I love space so much too, because fuck, this stuff is so hard to like even comprehend. 10 trillion years. Like, dude. I'm done.
We said this in the
nerd now.
we said this in the intro. The universe itself is 13.8 billion years old. 13.8 billion. So 10 trillion years. Oh my god. I love space, but I hate the math of it. Because motherfucker, like how old can something get? Okay? I thought Betty White was fucking old, okay?
You feel real bad about that when she like finally kicks the bucket at like 120.
She won't fucking die. She's not gonna die.
It's like a race between her and the Queen of England right now.
I know. Like what the fuck, dude? These people? Okay, I know we're sidebar. When is this gonna happen? Because I feel like I could ask them about how Abraham Lincoln ran the country. Like, like how fucking long have they been here? I'm not saying I want them to die, but motherfucker, there's only so long you can stay on this plane of existence. Oh, fuck.
Yeah, I love you, Betty White. Don't die.
Yeah, don't.
Please don't.
Please don't
go yet.
The Queen of England, I'm going to piss off our UK viewers. I'm going to leave it alone. Okay, so there are also supergiant stars, and yep, you guessed it. These are the largest stars in our universe. Supergiants are humongous and and are dozens of times. Oh my god! I love when I write sometimes. But they're dozens of
myself too.
But they're dozens of times the mass of the sun, and dozens is taking it very fucking liberally because they're fucking way bigger. Because these stars consume their hydrogen fuel at an accelerated rate, they die out only after a few million years. When a supergiant star dies, it creates a supernova explosion and completely disintegrates in the process. As you can see, stars come in many different masses, sizes, and colors by knowing... Stars come in many different masses, sizes, and colors. By knowing more about stellar evolution, we can understand more about our universe. And did you know there are over 100 billion stars in our universe? Because I kind of figured that because I do kind of have a grasp of the scope of the size of our universe. But, and at Cosmonova, you can name all of the fucking brightest ones. So let's name a star so that we can be part of our universe for as long as that star lives, and which, as we know now, is basically for infinity and beyond. If you wanted to fucking name a star, you can go to Cosmonova and just name one, because there's so fucking many to choose from. That's why I wanted to put this in here, because I really fucking want to name one, and I feel like everyone should name one. Chris, let's name a star right now. Let's go.
Let's name it after our podcast, man.
What? Okay, so do you really will it have like a numerical designation? Like, do we want to call it like Tipler's 2 cents 38.7G?
What's the 38.7G for?
Nothing. It doesn't make any fucking sense. But that's how they name stars. It's always like 387F GF2 has a really unique elliptical pattern. You're like, you couldn't just name it like Bob 7 or some shit. Like, I get the numerical designation, but it doesn't have any like actual designation for I just don't get their naming process in general. Because, I mean, I feel like NASA names them, but they don't really pick one. But anyway, finally, we reach neutron stars. And these are when stars are between 1.35 and 2.1 times the mass of the sun. These stars don't become a white dwarf when they die. Instead of an immense supernova explosion causes the star's death and the remaining core forms a neutron star. This star earned its name due to the extraordinary way it's composed, which is entirely of neutrons. And to put this into perspective, the density of a neutron star, a teaspoon of a neutron star material would weigh 4 billion tons. A teaspoon. If you took a spoon and scooped it like Nesquik, it would be fucking. I took one too many shots, motherfucker. Okay. But seriously, like how fucking insane is that? This happens because when the star has an intense gravity that crushes the electrons and protons together, it forms neutrons. If the star is more than 2.1 times the mass of the sun, and this sun meaning our sun, then the supernova explosion will turn into a black hole, which leads us to black holes themselves, which are insanely interesting interstellar anomalies and not just a Pornhub category.
I should have seen a joke like that coming.
Yeah. That's why I don't highlight my jokes, man. I know you weren't looking. Oh, fuck.
Anyway, as Sean has said before, the creation of a black hole and a neutron star are pretty much the same, if not just a coin toss for which entity will form. But there are many versions of what a black hole can be. Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. These black holes are very, very tiny, but have the mass of a large mountain. Mass is the amount of matter, or, stuff, for lack of a better word, in an object, and just like any sort of object. Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the sun. There may be many, many stellar mass black holes within the Milky Way. The largest black holes are called supermassive, which is a fantastic song.
Oh, yeah.
And I'm forgetting the band right now, but The Muse. Fantastic song. Supermassive black hole.
I'm going to listen to that as soon as we're done.
But yeah, supermassive black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way is called the Sagittarius A, because we all know Sagittarius people are massive black holes that just suck other things into it.
Yeah, exactly.
I'm just kidding. Aren't you
Sagittarius?
No, I'm Capricorn.
Capricorn, that's
I
what
just
it
thought
is.
I'd throw that in there for some fucking, somebody that was listening that's into that stuff.
I'm not gonna lie. I wanted to make a joke making fun of because I almost mixed up astronomy and astrology earlier whenever I was writing this. Fuck it. We're gonna make a whole episode. We're gonna talk shit about astrologists. Okay, sorry. Go ahead.
But yeah. Anyway, the one at the center of the Milky Way is called the Sagittarius A, and it has a mass equal to about 4 million suns, and that would fit inside a very large ball that could hold a few million Earths, which is pretty fucking crazy. Also, a black hole cannot be seen because strong gravity pulls all the light into the middle of the black hole, so it's just absolutely devoid of light. But scientists can see how the strong gravity affects the stars and gas around the black hole. Scientists can study stars to find out if they are flying around or orbiting a black hole. When a black hole and a star are close together, high-energy light is made. This kind of light cannot be seen with human eyes, but scientists use satellites and telescopes in space to see the high-energy light. And that shit blows my mind, too. Just the technology we have to be able to do this stuff, man. It's absolutely insane.
Yeah, recently we just took a picture of that shit, and it is the worst picture I've ever seen, but it's still so inspiring.
Just full of shit that we can do that.
Yeah,
it's amazing.
Yeah, because granted, for us to actually be able to take a picture of a black hole, it has to be okay. So how the gravity of a black hole works is essentially it condenses the light. So if it's super dense, it's just gonna absorb the light anyway. But some of these black holes can create, I think they're called accretion disks, and they make essentially rings around the black hole that can still emit light, because of how massive the black hole itself is. So it won't be absorbed. The light won't be absorbed because of the mass of the black hole. Because the bigger the mass, I think it like weighs into like the pole or some shit like that. So like technically, I think if like technically we can orbit a black hole as long as the warmth and light of it was sufficient to match our sun. Because we're going to talk about this more later, but yeah, like we can technically do that, but it would have to be supermassive, and like if there was like a black hole the size of like our sun or just our planet, fucking we'd be gone, like no problem at all. Just because it's young and like the smaller in mass it is, the harder gravitational pull pulls in. So yeah, God damn it. Okay, I know I've said this before, but I love space. Anyway, another phenomenon caused by black holes are quasars, which is an extremely luminous active galactic nucleus, in which a supermassive black hole with a mass ranging from millions to billions of times the mass of the sun is surrounded by a gaseous accretion disk. I was right. Hey. As gas in the disk falls towards the black hole, energy is released in the form of electromagnetic radiation, which can be observed across the electromagnetic spectrum. The power radiated by quasars is fucking enormous, and the most powerful quasars have luminosities thousands of times greater than a galaxy such as the Milky Way. So a single quasar can have more light within it than an entire fucking galaxy. How goddamn bananas is that? Like, oh my god. So anyway, the next one isn't necessarily caused by a black hole, but rather the potential creation of a black hole. In gamma ray astronomy, gamma ray bursts, or GRBs, are extremely energetic explosions that have been observed in distant galaxies. They are the brightest and most energetic electromagnetic events known to occur in the universe. Bursts can last from 10 milliseconds to several hours, and after an initial flash of gamma rays, a longer-lived afterglow is usually emitted at longer wavelengths. And by those wavelengths, I mean like X-ray and infrared and stuff like that. So different spectrums of light. The intense radiation of most observed GRBs is thought to be released during a supernova or superluminous supernova, as a high-mass star implodes to form a neutron star or a black hole. A subclass of GRBs, or the short bursts, appear to originate from a merger of binary neutron stars. And binary means like two neutron stars, or two stars in general that orbit each other. The cause of the precursor burst observed in some of these short events may be the development of resonance between the crust and core of such stars as a result of the massive tidal forces experienced in the seconds leading up to their collision, causing the entire crust of the star to shatter. The sources of most GRBs are billions of light years away from Earth, implying that the explosions are both extremely energetic. Typically release as much energy in a few seconds as the sun will in its entire 10 billion year lifetime. That's how much fucking energy these things have. And extremely rare, which means they only happen a few galaxies per million years. And all observed GRBs have originated from outside the Milky Way galaxy. Although a related class of phenomena called soft gamma repeater flares are associated with magnetars, which are hypermagnetic neutron stars within the Milky Way. It has been hypothesized that a gamma ray burst in the Milky Way pointing directly towards Earth could cause a mass extinction event, because it's basically a solar system size fucking laser. Chris, what, like, oh my god, what do you do? Like, we see movies like Armageddon and shit, and we think that, like, oh, we can defend against an asteroid, but a gamma ray burst, like, what the fuck are we gonna do? Are we just gonna make a giant planet-sized Iron Man shield to protect ourselves?
Yeah, and it's kind of like earlier when we were talking about the sun and stuff, and I was like, I want to save that for later, because that is one of the most terrifying situations that I can think of, is the sun just deciding to, explode. And this is kind of the same thing. It's like, there's nothing we can do. There is nothing we could do about it. And that fucking terrifies me, because I'm like, even as all-powerful as some conspiracy theorist mode of me might think the government is. I don't think they're powerful enough to defend against some sort of fucking gamma ray laser that's just originating from out in space somewhere. Like, how are we going to defend against that?
Yeah, because
that
even if
shit terrifies me exponentially more than anything else.
Yeah, even if we had like aliens and shit on our side, what the fuck are you gonna like? Okay, say like we had the production of a warp drive, which, if you didn't know, the warp drive is basically it's not a light speed drive. It's basically, imagine a ship having like grips on the universe or like what the fuck are they called? Like grappling hooks. Like, imagine a ship having theoretical grappling hooks, and you can fucking send them thousands and thousands of light years away, and it hooks on to this like space time, and it just pulls your ship there because you're technically moving space. That's what a warp drive is. You're moving space around you. As powerful as aliens could be, that like could maybe create a warp drive, what the fuck are you gonna do against just a natural universal disaster such as a gamma ray burst? Like, fuck aliens. The universe itself scares me way more than aliens. If aliens ever visited us, like, I wouldn't care. Like, I mean, I'd care, but like, as far as like in the scope of like,
I'd be more interested than scared, I think.
Yeah, like it'd be cool. But I mean, like, as far as like a potential disaster, like, we can be obliterated at any fucking second at any time. That's why I have a point to make later, Chris. Okay, sorry, go ahead. But yeah, just it's fucking terrifying.
Yeah, anyway, if we tried to cover all the cool shit in space, this would probably end up being like a 12-hour episode because, you know, we basically only covered our solar system, stars and black holes, and there's just so many awesome and terrifying things that happen from the creation of existence of just, you know, those two. So let's do one more exercise just to show you how fucking massive the universe is. We're going to read off our interstellar address as well as give a few details on each section. So me and Sean basically live in separate cities, but let's skip the semantics and say we live in Phoenix. We live in Phoenix, Arizona. No fun facts about Phoenix or Arizona other than it's where you get gas and watch people stab each other over a gas station sandwich at 3 a.m. While you're just trying to fucking make it to LA. Might sound familiar to somebody here.
Yeah.
Anyway, Arizona is within the United States of America. The United States of America are on the continent of North America, and North America is on planet Earth. Planet Earth is within the solar system, filled with all the planets we talked about earlier, as well as an asteroid belt, a nice warm sun, and it's 4.25 light years away from the next closest star, Proxima Centauri. By the way, so we can get a firm grasp of the term light year, I'm going to tell you this. A light year is a unit of astronomical distance equivalent to the distance that light travels in 1 year, which is nearly 6 trillion miles. If you go the speed of light, you could go around the Earth 7.5 times in 1 second. Fucking nuts.
Yeah.
Anyway, back to our interstellar address. Beyond the edge of the solar system is the spherical Oort cloud, a region of interstellar space that's home to icy comets. Astronomers know very little about it, but every time you go stargazing, you look right through the Oort cloud at what's beyond. It's from 2,000 to 200,000 astronomical units from the sun, which is about 3 light years. So, explaining a light year is helpful in this instance. After the Oort cloud is the local fluff. We're located on the edge of the dust clouds between stars and the Milky Way galaxy. It's an area of space that has a slightly higher density of hydrogen gas, the most abundant molecule in the universe. In 2019, researchers in Antarctica found dust produced by stars exploding as supernovas within the fluff. Which, yeah, that's crazy. I didn't know any of that stuff. We're currently moving through an egg-shaped region of hydrogen gas in space called the local bubble, which is the next part of the address, and our 40,000-year journey through it is almost done. We're just 10,000 years from the other side. Traveling with the sun through this bubble are about 63 other stars, though only about 13 are as massive as the sun.
And after, it's so fucking crazy how big this place is. Anyway, after that is Orion's Arm. See, our Milky Way galaxy is a spiral galaxy consisting of flat rotating disks containing star gas and dust with a central bulge in the middle. And when we look up at the Milky Way, we're actually seeing the Sagittarius Arm. I don't know about you, Chris, but have you looked up at and seen the Milky Way? Like the big ring or the, you know what I'm talking about? Like the fucking across the sky. Like, have you actually seen the Milky Way technically?
No, I haven't.
You haven't? What the fuck are we doing here, bro? It's so goddamn beautiful. Okay, so next time you go camping in a really fucking dark area, like it has to be dark. You can't be in the city. Go out, and it might depend on where we are in the year because, you know, rotations and all that shit. But just look it up. Go camping during that section, and please fucking look up at the sky because the Milky Way is fucking beautiful. But I digress. So, like, the actual, what we're looking at that section is actually Orion's Arm. Or not Orion's Arm. It's we're seeing the Sagittarius Arm. We're in Orion's Arm. My bad. And this contains the central bugle of stars. We, however, exist in a local bubble of the Orion's Arm, and from there our sun takes 230 million years to orbit the Milky Way's galactic center from 27,000 light years away. And then it's the Milky Way galaxy, a spiral galaxy that is 200,000 light years across. Our home galaxy hosts up to 400 billion other suns. Excuse me. It's estimated there are at least 100 billion other planets in the Milky Way, with up to 10 billion planets potentially supporting life. Oh my god, I want to play Mass Effect so bad now. Then comes the local group. Galaxies in the universe are found in groups. This unimaginative... unimaginatively named group of about 80 small dwarf galaxies orbits two, not 4, 2. They orbit two big galaxies, which are the Milky Way and the Andromeda Galaxy. We're in the Milky Way. Our neighbor is the Andromeda Galaxy, and then there's, some think that the two big galaxies will collide in about 4.5 billion years. So, you can wait a minute. It's not going to happen anytime soon. And then comes the Virgo supercluster, which is home to about 100 small groups of galaxies, including our local group. And then finally, the what the fuck is it? The Laniakea? Yeah, you're right. It is the Laniakea. The Laniakea supercluster. And the Laniakea is a galactic city, which is a fucking dope-ass name. Groups of galaxies are themselves found in clusters, all interconnected in a web of filaments in which galaxies are strung like pearls. So a huge structure like Laniakea supercluster is 500 million light years in diameter and contains 100,000 galaxies. Laniakea is Hawaiian for immense heaven, and it's home to the local supercluster. Beyond Laniakea is the observable universe, estimated to be home to 2 trillion galaxies. Dude.
2 trillion galaxies. 2 trillion galaxies.
Motherfucker, bro.
Like, just put that into perspective in your fucking mind. Like, that is nuts, dude. Fuck.
Okay, so me and Chris are very inebriated.
Yeah.
By the way, note that term observable universe, Chris. Meaning we can't fucking see beyond this point. What the fuck? But, okay. But that also means that, for now, that's our interstellar address. However, we haven't mentioned the rarest thing inside the universe, and that is sentience. us, the human race, this is the point I was trying to make earlier, by the way. It might not just be us, but I digress. The point is we're inside an explosion that spewed stardust all over the place, and that stardust formed planets, and one of those planets formed water, and water made life, and life made better life that had the ability to observe and report. Making it more simple, the universe is literally defined as all existing matter and space considered as a whole, so humans are potentially the only sentience of the universe. Unfortunately, that might be true, but that means that we're the universe observing itself. Isn't that fucking insane? Tell me that's not goddamn bonanza, okay? Like, because, like, by definition, we're the universe, technically.
Yeah, right.
And, like, and that's the thing, like, okay, we're talking about religious experiences earlier, and I have my own view on religion. I'm an atheist, technically speaking, but as far as, like, the potential of the creation of God itself, or, like, the existence of God, I mean, that kind of goes into dimensional planes and stuff that I'm not going to explain right now, but essentially speaking, scientifically speaking, I know that God could exist, but I don't choose to put faith in him. And
Agnostic,
that's...
then.
Yeah, I guess you can say agnostic, but I choose to not put faith in him. So at this point, like, with the universe, the creation of the universe and the existence of the universe itself, like, we are the universe. If we're, like, think about if humans were the only ones to exist, or even if life were to exist, because even if life existed throughout the universe, that even outside of our observable universe, that's to the point that, like, it's still super fucking rare for life to exist within the universe. Because if it exists outside of our observable universe, then, you know what I mean?
Yeah.
But still, how rare life is, and for us to observe the universe is the universe observing itself. And I know I know that you're still very scientific mentally and stuff like that. So how beautiful is that thought outside of just believing in God? It's, himself.
Yeah, like I said, it really is incredible. Like, even just shoving religious thoughts and views aside, it's insane. It's fucking insane, like you said. It's just it's hard to even comprehend that we could just possibly be the only life in the universe, the only sentience in the universe, and like you said, we're basically just the universe observing itself. There's just so much about space and about the universe that we don't understand, and that I don't think humanity will ever understand, and it just makes it all that much more intriguing.
Yeah.
Yeah, but I mean, like I said, if I were to put my religious views on it, that's also part of what makes me believe, because it's just hard. It's just so hard to believe that out of all the things that could have happened, this was just some random accident,
Yeah. And that's...
I'm not trying to convert anybody, but, I like to... The logical part of me likes people to have those open discussions within themselves. That's what I did, and that's why I've gotten to where I am with my religious views and my logical views. Yeah,
and we've talked about this before on the show, where you basically had a series of events happen that in no way could be coincidence. So you're like, yeah, you know what? You exist. I believe it.
Yeah.
And
it just got to the point where, like you said, it was just, there were so many of those quote unquote coincidences where I was like, there's no way for this many random things to just happen randomly. There's mathematically no possible way.
And by the way, we mean this, like, personally, not like the creation of life or anything. We mean this personally.
Yeah, not with everybody. Like, experiences differ because life is different for everybody. But just in my personal experience, there's too many of those things where it's just shit lined up the way it does, and I'm just like, stuff's not an accident. It doesn't happen on accident. I don't believe it does. I like to think that there's a purpose and organization to life, as random as it is at times. I don't think it's random.
Yeah, and that's the thing where I fall in love with space, because ultimately you are always forced to think about your significance within the universe itself. It doesn't matter who the fuck you are. Because when you actually get that visual in your head of how fucking potentially insignificant you are, you always think to yourself, why am I here? And it becomes existential. So that's why whenever I talk about space, it always fucking goes to religion. It always goes to religion. And personally,
They
like
really
I said,
do go hand in hand.
yeah, and personally, I'm not religious, and like how Chris said, like I'm agnostic. I believe I'm atheist just because I don't really believe or like have. It's not that I don't believe. I don't have faith in God. I won't bend the knee essentially, but I know that He could exist because for something this big, like the universe, we're not even mentioning the dimensions, and there are fuck tons of dimensions. There's up to 10. And we're not going to talk about this right now, but yeah, essentially, God could exist. And I always would rather believe in myself than bend the knee. And, Chris doesn't necessarily bend the knee, but he does have that existential thing where he just like acknowledges the fact that God could exist. And I'm not trying to make this religious at all, but whenever you're thinking about the entire scope of the universe, like how in the fuck are we here? Like, and fucking really, it might be a god. I'm not saying it's not.
Yeah, who knows? Honestly, I mean, like I said, I believe, but I'm still, the logical side of me is like, honestly, who really knows? We don't know for certain. Nobody can say they know for certain. If you feel like you know for certain in your heart, good for you, but you really don't. And I mean, that's just the plain facts of it.
Yeah.
I 100% believe in God, but He could not exist. There really is that, possibility, and it really could just be random coincidence that we're here. And either way, I mean, end of the day, let's just appreciate the fact that we're here, because as we've laid out, it is so impossibly impossible that we're here, but yet we're here. And that's fucking amazing.
Yeah, well, let's just be happy that we get to be the universe observing itself. So, let's get down to talking about the fucking awesome movies that involve space. So, guys, it's time for Tipler's Take 2.
Come on. So what's holding everything up here?
Art department.
So the grips are holding us back?
All right, try that take one more time.
1 second.
Hey, quiet on the set!
Tipler's Take 2, Mark.
Action!
Okay, guys. So, Tipler's Take 2 in this episode, it's fucking great. There's so many good space movies. I'm starting off this list with Interstellar. It is a movie by Christopher Nolan. We actually mentioned him in our other show called Cinematography, if you want to check out the newest episode, which will be up next week on Monday. But Interstellar itself is fucking great. It also brings into perspective not just space and relativity. It also brings in the concept of higher dimensions and stuff like shit. Stuff like shit. Jesus Christ.
It also has the most cinematic accurate version of a black hole, right?
Yeah, not a black hole, a wormhole, and a black hole. Actually,
or not even cinematic, but I think just overall it was the most accurate, right? Like even just scientifically speaking.
It was. I think it was praised by many scientists for being very scientifically accurate. Christopher Nolan, of course. Me and Chris suck his dick all the fucking time. We love this director.
I don't care. He's amazing.
Yeah, he's a good director. And what's his name? Matthew McConaughey is fucking great in this movie. I'm not even gonna complain. Usually, like, Matthew McConaughey is Matthew McConaughey, but he's a terrific actor, and he's a terrific actor in this movie. And I'm probably gonna watch this after we finish this, honestly.
And his acting style and everything doesn't really overpower the film like it does in other ones. So
yeah, no,
it's a really great film though. It's a good one,
and it's very emotional, surprisingly.
Mm-hmm.
Another movie that has to do with space is, of course, and how the fuck am I gonna ignore this? Nope, that's not the kind of alien I want. God damn it. Is Alien. This is God damn it. Why can't I just have the original fucking thing? Chris, you wanna
Mr. Ridley Scott.
Yeah, you want to talk about Alien so I can find a fucking picture that actually works.
And yeah, I can't remember. Did it come out in the late 70s or was it the 80s? I'm not sure, but the original Alien. Everybody should fucking know this. It's with the xenomorph, the big alien with the fucking the giant head shit.
Yeah.
And it's got the extra mouth thingy that comes out. You guys should all know this. Very iconic movie, and it's still pretty great actually. Like I just watched not just watched, it was like a year ago, but I watched the original one quite a while back, and it still holds up, man. That movie is fucking great. The atmosphere and everything that it sets up is fantastic. Sigourney Weaver getting, her chance to shine as like a frontline heroine. Good movie, man. Overall good movie. So if you haven't seen it and you're into like, horror sci-fi movies, it's a good one. Obviously, you should check this out because a lot of newer movies are based off of it. So,
yeah. Another one is Star Trek. If you guys don't know what Star Trek is, I don't know what to do, man. Like,
yeah,
I give you guys,
you guys should know this.
I give you guys so much leeway. Like, I really don't know. If you don't know what Star Trek is, like, fucking go home. just do some homework. I don't fucking know. But Star Trek, is a fucking very popular show. I don't even remember when it was initially released. I feel like it was like the 60s, 70s. Of course, having a couple adaptations recently, even like a show adaptation pretty recently, I think. But they're good. The whole premise around the show is essentially going outside of our observable universe to figure out what the fuck is out there, because it's pretty much what we've always wanted to do. And what, like, in this universe, what they want to do is they want to just keep expanding and keep, and Star Trek also does have other alien races and stuff. So please check out Star Trek, even if it's just a reboot. Because I know the original is probably hard to watch nowadays, but not hard to watch for new viewers anyway. But still, check out Star Trek. Just the reboot. I don't give a fuck. It's so good, and it has such a great premise. And fucking, every episode's different. So check it out. Another one is Star Wars. Chris, you want to go ahead? I gotta.
Another one, iconic. There's no way you can't know Star Wars. Maybe you haven't seen Star Wars, but there's no way you haven't heard of it. If you haven't heard of it, what are you doing? What are you doing? There's no way. Star Wars, obviously, I love Star Wars, and it's definitely going to be one of those things that I want to talk about on cinematography here soon. Because I have a lot of opinions about the newer stuff. I'm not such a fan of the new trilogy, but as far as the original trilogy goes and the prequels, big fan. I would say check those out and just pretend like the new trilogy doesn't exist. That's just my personal opinion, but they're fantastic. Not for scientific reasons, but obviously just for like sci-fi action schlock that you want. Great go-to movies for that. And I'm not a big sci-fi guy, but Star Wars is right up my alley. It's hard on the brain, but easy on the eyes.
Yeah, it's not. I think like even just the most recent installment of the Star Wars universe is cinematically speaking anyway, The Mandalorian is just so fucking good. The
Mandalorian's amazing. Even
so
if you don't
good.
like Star Wars, dude. Fuck.
Yeah, you don't even have to watch Star Wars. Like, there are, like, little nuances here and there that, like, you're like, oh my god. Like, if you're really a big fan of Star Wars and you read the comics or do your research anyway. But, yeah, The Mandalorian just fucking kills it in every which way. I think only this last season they did a little bit of fan service, which was fucking great fan service.
It was all very much appreciated.
It was... Motherfucker. I'm not going to ruin it because it's still pretty fresh, but please check out The Mandalorian at least. Another one is Moon with, I'm going to look it up. Hold on, guys. I am so sorry. I love you. Moon movie. Oh, how fast can I type?
Tell you, or you just want to look it up?
No, I got it. Okay, so, it has... Please. All right. So Moon is a 2009 science fiction film directed by Duncan Jones and written by Nathan Parker. And the film follows Sam Bell, which is played by Sam Rockwell. That's all I need. Now I just need a picture. So, Chris, you want to keep going with Moon? I'm going to look up the picture for it.
Well, it's kind of hard to give away the plot on this one because the big part of the plot is kind of a twist in the movie. But basically, this guy's on the moon, maintaining some sort of space station on the moon. And I can't remember the specifics of it, but
he's getting he's mining a mineral by himself.
Yeah, and so he's getting this mineral that's really needed on Earth, if I remember correctly. And he's the only one up there. He's all by himself, and he ends up suspecting that there might be somebody else up there with him. And don't really want to give any more away than that because it is a super cool movie. I love the atmosphere of this movie, and I love Sam Rockwell. He's amazing as an actor. And the little twist on it and stuff is really cool. And it's another one that kind of goes, I wouldn't say it's too smart or anything, but it has a good little twist, and it gives, makes you think a little bit and has a little bit of tugs on your heartstrings a little. So it's a good movie. Just check it out. It's really good.
Yeah.
And it's not a horror movie, by the way, but it's a little bit of a thriller.
Yeah, you're not wrong. Another one is The Martian with Matt Damon. This movie was so fucking good. This is one of those movies that I can actually, Chris has a couple of movies that I always give him shit for being able to watch over and over again. Sherlock Holmes, Cable Guy. The Martian is one of my movies that I can watch over and over again. I absolutely fucking adore this movie. Just because of, the pure nerdism and, the fact that he's able to survive on Mars for quite a while. And, obviously this isn't based off a real story, but the science there was also just like Interstellar, as in it was praised for being very scientifically accurate.
You're gonna hate me, but I haven't seen it.
You haven't seen The Martian? Motherfucker! Dude, The Martian
I know, there's just some movies that I miss out on, and that was one of them. I had every intention of watching it. I remember when it came out in theaters. I remember when it was, available to stream and all that stuff, and I haven't gotten around to it. I don't know why, but...
Yeah, no, first thing that you get a chance, you watch The Martian, because it's a great movie. Another one, Chris, I think you know this one. Pandorum, you want to explain that?
Yeah, this one's a horror movie, so if you're looking for a horror movie set in a sci-fi setting, this one's a pretty good one, actually. I like this one a lot. I've watched it a good couple of times. Basically, a guy wakes up on a derelict ship and can't really remember anything that's going on, and he just ends up finding out that it's overrun with all these cannibalistic humanoid type people. And as the story develops, he just starts finding out, things about the people and other survivors that he's finding on the ship aren't quite so what it seems, and there might be, something else going on. Kind of another one where it's really hard to give you plot details without giving anything away, but if you're a fan of people being in some sort of isolated environment where they're being hunted down by mutant cannibal people, then this is right up your alley. And like I said, it's got a few twists in it too.
Yeah, Pandorum has a very good twist that is very easy to suspect, but for some reason you don't.
But yeah, no, it plays out well, I think. Anyway, I can guess twists fucking easy, but I don't remember guessing this one, and I also thought it was just I don't know, it was a good twist either way. Even if you were to guess it, I think it just fits for the movie.
Yeah. Oh shit. Hold on, guys. There we go. Another one is Gravity. It has Sandra Bullock and George Clooney. This movie,
another one I haven't seen.
It's pretty good. It's very isolated. It's very isolated incident, but the story in it is super simple. It's basically some debris from destroyed satellites comes and wrecks the ISS or one of the space stations or some shit that they're on. And then at that point, Sandra Bullock and George Clooney are just trying to survive to get on a shuttle to get back to Earth, because at that point their mission failed and they're just trying to fucking leave. And there's really nothing else to it. It's just really fucking cool to see like a very suspenseful story about an astronaut just trying to survive the most like minuscule event, because it really is just some debris just fucking shreds through their station, and that's it. That launches the whole fucking story. Another one is Sunshine, which I really love this movie, but I haven't seen it forever. So this one has Cillian Murphy in it, and it's, I think. Oh yeah. Never mind. I remember what it's about. So the sun is
the sun dying, right? The sun's going out.
Yeah, the sun's dying, and basically their whole job is to go and nuke it to try to. God damn, that's a terrible
reignite
picture.
it.
Yeah, to reignite it, and there's a couple things that ends up happening. Like one of the I think the captain ends up going insane, or something like that, and.
Yeah, it gets a little weird at points, but I do remember liking this movie. I remember it being pretty good. Like you said, the captain, I don't want to give anything away, even though it's been out for a while, but the captain ends up going crazy, or at least the captain that was on the former mission, I think it was, ends up going crazy and stuff. But other than that part aside, it's pretty good, straightforward, like scientifically based movie.
Yeah,
for the most part.
Like, I think the only scientific thing that like lures it is like the time it takes, like the 8 minutes it takes for the light from the sun to reach Earth. So it's like basically when it shines brighter, you'll know we did our job. But then at the end of the movie, that happens, and you're just kind of like, oh. But yeah, the movie itself.
I was gonna say it's very much like a mood movie, where it's like one of those like just kind of like gives you a certain feeling. At least that's what it was for me. It just kind of puts you in like a certain mood, and that's why I liked it. It's kind of like dark, brooding, if you're feeling like sick or something. Like it's one of those movies. I don't know.
Yeah, I do like Sunshine though, and I like Cillian Murphy, so check it out. The last one on our list is it stars Jennifer Lawrence and Chris Pratt, and it's called Passengers. This movie is upsetting and really good at the same time. So, did you ever see Passengers?
Yeah, I actually went and saw it in theaters.
Okay. So, basically, this is a futuristic take on Sleeping Beauty. Like, tell me I'm wrong?
Pretty much.
But
with a little bit of twist to it, but...
Yeah, so... basically, it's this giant ship. The human race is at a point where they're actually colonizing planets, and they're on this giant ship where they're sending a bunch of people that are in cryosleep to go live on a planet to start, building it up and colonizing it. So Jennifer Lawrence and Chris Pratt's characters both go because I think like Jennifer Lawrence is a writer, Chris Pratt's an engineer. Chris Pratt's character doesn't have any real reason to be an engineer in their society at that point, because everything is just easily replaced, and at that point it's just kind of a moot point to be an engineer because there's no innovation happening. But essentially he accidentally wakes up caused from a asteroid, or like the ship going through an asteroid belt, and it ends up waking him up by accident. So he is alone on the ship for a couple of months, and he ends up falling in love with Jennifer Lawrence when he's walking through the cryosleep chambers, and he sees
just
her
by
asleep.
Looking at her, basically.
Yeah, so it's like love at first sight. So like a complete fucking piece of shit, he wakes her up, and they essentially end up falling in love, which, if you have any inkling of how movie progression goes, obviously she finds out and stuff like that, but there are also good points to be made that kind of defend him and all that stuff, and really good visual aspects on the movie as well. Good, like, spacewalking scenes and stuff like that. So, please check out Passengers.
It's pretty decent. Your average moviegoer would like it, so.
Yeah, and honestly, like, it's not a bad plot. It's a simple plot, but it's not a bad one. It's just, I think it gets me more just because I like space as much as I do, and I like that idea a lot. So
it's another like Star Wars, easy on the brain and easy on the eyes. So
yeah. So yeah, check out Passengers. Not a bad movie at all. Pretty good. But as there are fucking so many space movies that I can mention that I've probably mentioned before, like Event Horizon, Predator to a point, and stuff like that. I've mentioned that before. It gets to a point where it gets very convoluted and stuff. I just wanted to put the ones that are very scientifically accurate or very that have a very heavy fan base. But yeah, so today that is the end of Tipler's Take 2.
And cut.
Okay, everybody, that's a wrap.
black holes, gamma ray bursts, and the mind-bending comprehension of our universe. We sure hope you enjoyed listening to today's episode about outer space, the planets, and other cosmic bodies. If you did, please consider subscribing or following to the show on whatever platform you listen on. That way you can stay up to date whenever a new episode is uploaded. Please also remember to drop a review if possible. This helps us to personally improve the show as well as help us gain new listeners.
And to help us keep up to date with the show, you can also check out our Facebook and Instagram pages as well as email us personally at tipplers2centspodcast@gmail.com. If you'd like to help us support the show's financial situation, please feel free to visit represent.com/store/tipplers2cents and pick up a custom-made t-shirt specifically from highlight moments and jokes from the show. If you're itching for more content from us, please check out our previous episodes of Tipplers 2 Cents or tune into our new show, Cinematography, where we discuss a variety of different topics with all the wonderful world, within the wonderful world of movies.
And once again, thank you all for taking the time out of your busy day to lend us your ear and learn a thing or two with us. Tune in next time where we'll be learning about what's in our food, like GMOs and, all sorts of the other stuff that they put inside of our food. But until then, we will see you in the infinite void where we dare go where no man has gone before. Or maybe we'll just see you next time on the next episode of Tipplers 2 Cents.
Please remember to drink responsibly and think responsibly. Bye.
I just did that for myself because I want to know how it sounds later. And again, I hope you see it.